I'll just take you through an overview of the facility first of all, because it was our first TNA, so there's a few features we'd like to show you and potential collaboration opportunities going forward after the Visionair project, and then take you through what happened during our TNA that was earlier this year. So the Operations Excellence Institute was formed from a Higher Education Funding Council of England, HEFCE. They met us with 3 million of funding, together with 3 million matched by our partners here at the Operations Excellence Institute, so industrial partners who work with us through some of our research and collaboration opportunities. So the aim here was the Operations Excellence Institute was focused on manufacturing within this region. So we were developing novel teaching approaches, bringing together different levels of students. Ucranfield University is primarily a postgraduate university, and we only have MSc students and PhD students here, but over 3,000, so quite a large student population. And we're reaching out to reach educational partners from A-level college students, which is sort of 16 to 19, and undergraduate student institutions, so local universities, and working together with our MSc students and PhD researchers through educational projects focused on industry tasks, so things that industry problems want solved, and then moving forward to provide some solutions. So the facility, as well as providing virtual reality and augmented reality capabilities, is about engaging with industry and the wider region. So we'll just take you through some of the functionality we have here in the facility. You can see some of the earlier shots when we were just beginning to open the facility. So an illustration of the power wall or video wall we have at the far end, so high definition, and it's connected to an Extron screen switching, so we can change to different input sources. For the video conferencing, one fairly unique feature we have is the mobile screen. So when you have a guest join a webinar who normally is perhaps part of the audience, who's perhaps hearing a speaker who's, say, at the podium, we can position the mobile screen so it's behind the audience, so they get the same view when they engage, rather than being placed in front of the audience, which is kind of typical of some conference venues. We've also got separate breakout areas, and you'll see in a moment just some of the different things we have inside of these areas. So the telepresence capability, we've used a system called Video, which is similar to WebEx and Skype. It's got a quite good capability in terms of scaling up to a number of online participants. So with our system, with the hardware we've invested in, we can have up to 500 online participants, so we can do virtual conferences, and we're doing something with SERP later next year using the same capability. The space is configurable with a screen that can fold back, and we can create different layouts, so up to 3 different breakout areas, and each of those separate workspace areas have dual screen 55-inch high definition screens with additional cameras, so separate workspaces where people can dial in, or we can connect to remote locations, so whether it's an educational institute or some industry facility. We've got various cabling, Wi-Fi, one-line IP over television, and Crestron Air Media, which is a way to connect wirelessly to the screens in the facility. So lots of different flexible ways to use the equipment, and we can record and then broadcast webinars as well. And we've recently done one for the Ellen MacArthur Foundation for the one of their sustainability conferences, where we had some of our guest PhD students present some of their work. Right, so we also have some robotic telepresence robots, so we can really get interactive with some of the group work we do here in the lab. So these are robotic platforms, iOS devices, so controlled by a remote iOS device or mobile device, or even a desktop web app applications. So we've got a few applications of augmented and virtual reality we like to do in this facility. We've got 2 separate zones we've set up, the VR zone and the AR zone, and different immersion capabilities, integrating with some of the proprietary software we've got installed, and also some of the software used in manufacturing simulation, so agent-based modeling using Lano Witness. So we're aiming to focus on maintenance simulation, servitization applications, and a few other research areas from our partner centre. So talking about our camera setup, we've got something similar to the inertia setup at INRIA with the ART cameras, flight sticks and so on. Yes, quite Star Trek and very intuitive in terms of once we've had demonstrations with guests and visitors, people sort of get the grips of them quite quickly. The Lana Witness integration is a live feed from the software. So when you have agents moving around in this sort of 2D based simulation, it's then rendered in our visualization software, presented in 3D mode. We're currently going for an upgrade at the moment to the latest version of Lana's software, so we'll be testing that out at the beginning of the new year. So it's effectively a way of creating a new way of visualizing established agent-based simulation model, and we use those quite a lot in some of our related research. We saw the Oculus Rift earlier, and this is probably an early prototype photo, but we have a dev kit 1, so you can see the stats here. The resolution is already improved, so we've got the Oculus is now, I think, dev kit 2 with a HD panel in front of the device, so you've got 1920 by 180 for the maximum resolution, so that's 960 by 1080 per eye, and a 100-degree field of view, so it gives you a good level of immersion and great workflow with developing with Unity, as you may well be aware with your own kits. But we're still some way off what the human visual cortex is capable of. So with, I think we need to aim for at least 7,500 by 7,500 for a complete resolution match of what we see with our own eyesight. Of course, any younger people in the group will probably have sharper vision than us, people who've been around here for some time. So yes, talking about our H&D device, we've got the ST50, but it's got quite a good application for AR. It's got a vision pass-through. You can see this feature here with the cover removed at the front, so you can see the OLED displays, and they will let what's presented in front of the user through, so you can then have an immersive VR AR experience, so mixed reality, together with the ART tracking. So we've got a tracking marker that attaches to the rear of the device, and then with the 10-meter umbilical cord, you can walk around and see some of that immersion right in front of you. So we use that to test out some of our theories before we move on to different mobile devices. You can see some of the software we've got available for the VR setup, and it's called Visionair Render. It's an OpenGL-based application developed by our supplier, Vitalis. The company has developed out of Salford Robotics Group, and they've been in VR for some 20 years now. This software they used to develop their own in-house simulations, and now they've made it available to their partners and customers, and it's quite a capable system of loading up various CAD data sets from different file types and so on. You can create a complex scene and then start sequencing. It's got various scripting capabilities, so you can create simulations and interactions and different panels and controls within that visualization software. And yeah, we're still finding the limitations here and there, but we're pushing the boundary, and it's good to work closely with the developers to be able to add new features and integrate with different workflows. So some of the application areas we're interested in for augmented and virtual reality, this is linked to our partner center, which is, or parent center, sorry, the Through Life Engineering Services, an EPSRC funded group which works in different research areas and things like degradation mechanisms, obsolescence, maintenance training, self-repairing electronics. So when you have a piece of damaged hardware, it will self-reroute around the damage to continue operation. The whole concept of no fault found, which is the issues around a maintenance task. Say an aircraft returns to the flight deck and lands, and the fault reported can't be repeated on the ground because of the weather conditions. The operating temperatures are somewhat different when it's in the hangar. So things like heat and so on can change the flex or the circuit board and so on, and components will test out in the normal state, but then in operation will develop the fault. So it's to reduce cost in terms of the fault being reported and no fault found when diagnosed. Data visualization, so we're part of the facility here in the Operations Excellence Institute. This lab is all about visualization, presenting things like cost and system design at high definition. It's all part of our capabilities and things we like to build upon. So moving on to the transnational part of our exercise here, we have our guest was from Queen's University Belfast, Dr. Mazzano. She joined us from her facility and worked on a project which she had developed in the past using VR, and it was called Matemasis, and it was an opportunity to revisit some of the designs and experience she had with an earlier iteration of virtual reality some years ago now, and how she could adapt it for some more modern systems. So we started back in October. It was a 5-day, 1 unit of access, and focusing on manufacturing system simulations. So we were looking at this initial work of virtual manufacturing tasks, integrating the laboratory that we have here at Ucranfield, and then looking at a case study, an example which was part of what was capable in the system Matemasis, and looking at maintainability of complex assemblies, in this case an aircraft. So we looked at a number of requirements for this TNA. So some of the concepts you address with virtual reality, so some kind of powerful graphic or calculus system, so a way to visualize things at full scale using the active wall facility, and different input devices to be able to add your presence and the immersion within virtual reality, so the need or requirement for VR to apply to the Matemasis system. So we made use of the Visionair render software from Vitalis, and looked at importing some of the data sets that Dr. Mazzano brought with her. There were some initial issues with the import process. We had some various, because of the legacy of the file formats, we had to go through some conversion processes to enable them. So as always with these TNAs, you have some things to tackle during the visit, and so there's much preparation as you can prepare for is always a challenge sometimes in the event. So different characteristics to measure and qualify the results of the Matemasis simulation. So here's the illustration of what the Matemasis simulation manager is all about. It's the input focused on the output, so it's a collection of the virtual reality hardware solution, software solution. So it's maintainability driven design, collecting knowledge of the process of the maintenance, various analysis and methodologies for the manufacturability, looking at things of assembly criteria, tooling tolerances, materials within that maintenance task, the disassembly criteria, the mean time to repair, and frequency and cost of the maintenance task. So a variety of data preparations, scene preparations, assembly, disassembly, development environment, all part of what was considered with the Matemasis system. So we were focusing on the main landing gear of the aircraft. So this was disassembling the hub and the whole assembly to maintain and replace the brake plates for the aircraft, fighter jet aircraft, to slow down the landing egress process. So quite significant brakes, 11 brake plates assembled together, and then the maintenance task was focused on the disassembly of the whole complete assembly. So there's various models imported and then prepared together, aligned so it was sufficiently accurate, and then we looked on to the following procedure, what sort of maintenance tasks we should be focusing on. So things to add realism, the level of immersion, different light sources were positioned and textures and so on. An immersion environment as if you were the engineer in the scene, different tables of tools and so on presented next to it. And then an illustration of the process and visualization of the actual bolts and so on being removed as part of the task. So you can see here a few screenshots from the task, the focus on the brake disc assembly, and you can see the 11 discs are in place. You can see the black rings are the discs and the pads are the grey rings shown in between. The hub is the gold part with the grey cylinder in the middle. An example of the disc on the right hand side. So part of what the Visionair render software allows you to explore the CAD data as part of a hierarchy of components within the CAD scene. So the main thing was what we can manipulate the maintenance simulation for. So looking for a positive outcome for the feasibility of the maintenance task, what was detachable, what things were accessible in VR and also in the actual task to be defined, and what things could you manipulate with the flight stick input devices and so on. The aim was to have it so that an unskilled operator who was not familiar with VR could then employ and do the tasks. We did a fly through of the whole sequence, and on an automated strip it could be completed in about 4 minutes, but in actual real life it would be a significant undertaking to decommission the aircraft and remove all the parts, but a dedicated crew of personnel will be able to operate this in a reasonable amount of time, but not 4 minutes. So yes, in effect we've looked at the data produced from the simulation, and certainly it can assist with determining the functional requirements and improve the design of the Matemasis concept. In terms of results, we've looked at various approaches within the simulation, sequencing and ordering of instruction. Going forward, we will hope to perhaps develop a new version of the Matemasis simulation and look at ways to visualize the next component for removal, ways to highlight or clarify, perhaps with color coding or different ways of signifying information on the screen, so different overlay and perhaps applying mixed reality approaches. In terms of grasping, so integration with haptic devices, haptic gloves, that sort of thing, to give a more realistic maintenance simulation, so as you handle the objects rather than a sort of virtual point and click with the flight stick device. So, to conclude, the director of our institute is Professor Rajkumar Roy. Apologies he couldn't be here for today's session, but he's certainly open for any collaboration opportunities and conversations about the facility, and we're hoping to reach out to a wide industry of partners and people overseas and globally to work together with us here at the Operations Excellence Institute.